Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson about natural rubber. So far, in this unit, we have studied synthetic polymers. We have learned about the different types, their uses, their properties, and the various ways in which they are made. Now, we are going to shift our focus. We are going to study natural polymers, including rubber, carbohydrates, cellulose, amino acids, and proteins. We will begin with the lesson on natural rubber. Are you ready, students? Then let us get started. Natural rubber is also known as India rubber or caoutchouc. It is an elastic hydrocarbon polymer called an elastomer. When untreated, it has thermoplastic properties. Rubber was originally derived from latex, which is a milky colloid produced by some trees in South America. The latex is harvested by making an incision into the bark of the tree, and the resulting sap is collected and refined into a usable rubber. The commercial source of rubber is the Hevea brasiliensis, commonly known as the para rubber tree, because it responds to being wounded by producing more latex. The para rubber tree is a renewable resource. The purified form of natural rubber is the chemical polyisoprene. As we have seen, it can also be made synthetically. Both natural rubber and synthetic rubber have distinct physical and chemical properties. Natural rubber is a soft and sticky solid. It softens in hot weather and hardens in cold weather. In its relaxed state, rubber consists of long, coiled up polymer chains that are interlinked at a few points. Each monomer is able to rotate about its neighbor. This allows each section of the chain to make a large number of different shapes, like a rope that is loosely tied at both ends. When stored at room temperature, rubber stores enough kinetic energy so that each section of chain oscillates. Picture the rope being shaken strongly, and you will get the idea. When rubber is stretched, the loose chains are pulled taut. They are no longer able to oscillate. Their kinetic energy is released thermally, which means that it is given off as heat. Therefore, the entropy of rubber actually decreases when it goes from the relaxed state to the stretched state. Entropy increases when it goes from the stretched state to the relaxed state. Rubber relaxation is endothermic. For this reason, the force exerted by a stretched piece of rubber increases with temperature. This property of rubber is very different from most other types of material. Metal, for example, became softer as it increases with temperature. It is time for our first activity, students. Please look at the following phrases and fill in each blank space with the appropriate word. Do your best.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Let us review the answers together. Natural rubber is known as India rubber or caoutchouc. The commercial source of latex is the Hevea brasiliensis, commonly known as the para rubber tree. Rubber consists of long polymer chains that are interlinked. At room temperature, rubber stores kinetic energy. When stretched, the kinetic energy is released as heat. The entropy of rubber decreases when it is stretched. Therefore, rubber relaxation is endothermic. Were you able to use all the correct terms? Great work, students. As we have learned, natural rubber is thermoplastic. However, when natural rubber is heated with sulfur, the polymer chain will become highly cross-linked by forming bonds with sulfur atoms. The chains become shorter and so tighten more quickly for a given length of strain. The rubber becomes harder and can extend less. The properties of the rubber are fundamentally altered. This process is called vulcanization. Once rubber has been vulcanized, it ceases being a thermoplastic and becomes a thermoset. It is time for another activity, students. We have learned of natural rubber's basic properties and the process by which it can be made from a thermoplastic into a thermoset. We have also spent a number of lessons learning about the different types of synthetic rubbers that are available. Please form groups of 3 or 4 and discuss the following questions. What are some of the physical differences between natural and synthetic rubber? How might synthetic rubber be superior to natural rubber?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again. I trust you had an interesting discussion. As we have learned, natural rubber comes from latex. Latex is mostly polymerized isoprene that has a small percentage of impurities. This limits the properties that it can have. In addition, there are limitations on the number of double bonds that can be made between polymer chains in natural rubber. Even though natural rubber's properties can be enhanced through vulcanization, it is simply not as versatile as synthetic rubber. We know that synthetic rubber can be made from a variety of different monomers. These monomers can be copolymerized to yield a wide range of properties. The monomers can be produced pure, and the polymerization can be better controlled to give the desired proportion of double bonds between polymer chains. In other words, synthetic rubber is simply more useful and adaptable than natural rubber. That is all for today's lesson, students. We have learned about the production of natural rubber. We have also learned its properties, the process of vulcanization, and the differences between natural and synthetic rubber. Until next time, thank you, teacher. Thank you, students.